Hello everyone. I want to take a look at another vector operation called the dot product. So we're going to develop a little formula that is a useful piece of information that can tell us something about our two vectors. And to do this, we're going to start with two perpendicular vectors. Now remember, vectors don't necessarily have a location, so maybe we'll say that these vectors are both starting at the origin. Doesn't really matter, but if we do this, then they're in standard position. So then let's draw two perpendicular vectors. Doesn't matter how long they are, doesn't matter what they look like, just as long as they form a right angle. All right. Now let's name these terminal points. We'll name the vectors as well. So I'll say this is A. And then I'm just going to say that this has coordinates A1 and A2. And then for my second vector, I'll call this one B. And this has coordinates B1 and B2. All right, and then just to name these, we'll say that this is vector A, and then that this is vector B. Now, if I connect together the terminal points of these two vectors, like so, this resultant vector, we'll call this one, so it's going from B to A, like this. Now, what I want to do is I want to come up with a couple different ways that I can represent this resultant vector here. All right. The first way, and maybe the most obvious one, is because we set up these vectors to be perpendicular, we have a right triangle. So that means we can use the Pythagorean theorem. So the first way with the Pythagorean theorem, we have the length of vector A plus the length of vector B squared is equal to the length of the resultant vector squared. So the two legs squared is equal to the hypotenuse squared. All right. Now the second way, since we did name points A and B, to find the length of this, we can also use the distance formula. So the distance formula we're going to end up with, so the length of the vector BA is going to be equal to, and then we subtract our x values, so we have A1 minus B1 squared, and we subtract the y values, A2 minus B2 squared, and it's the square root of all of that. Okay, so now we have two different ways. They both represent the length of the vector BA. I'm going to work with this. I'm going to do a little bit of rearranging, a little bit of multiplying, and then we're going to see how this relates to our first way. So first thing, we can square both sides. That takes care of this square root sign. We're just left with what's underneath our radical. And so now you can see that these match. So what we're going to end up with is these two expressions need to be equal to each other because they both represent the length of this. So let's multiply this out. So we have a binomial squared. So we have A1 squared in the middle, A1 times B1, and then we have two of those. And then plus B1 squared. And then we'll do the same thing for our second one, and running out of room a little bit, but we have A2 squared, and then that should be minus 2 A2 B2 plus B2 squared. Okay, now all of this I'm going to take and I'm going to rearrange it a little bit. So our magnitude squared, and I'm going to group some things up so that we can do some substitution. So we'll do A1 squared plus A2 squared. We'll group those two things together. So that takes care of that and that. And then we have B1 squared plus B2 squared. We'll group those together. And then what we're left over with is minus 2a1b1 and minus 2a2b2. Okay, so now the reason I wanted to group these together is because these two pieces added together, a1 squared plus a2 squared, that is the same as the magnitude of vector A. That's how we define the vector, right? It's almost basically very similar to the Pythagorean theorem. So these two together, that is the same as the magnitude of vector A squared. The exact same argument here. These two, b1 squared plus b2 squared, that whole thing is the same as the magnitude of vector b squared. And now I'm left with all this. Each of these does have a factor of 2 in there, so I'm going to factor that out. So then a1 b1 plus a2 b2. All right. So this is still the magnitude of vector BA squared, and that has to be the same as what we got from the Pythagorean theorem. So if I set those equal to each other, from our first way, we end up with magnitude of A squared plus the magnitude of B squared, and that's going to be equal to this expression we got from the second way. Okay, now if we look at this a little bit and we study it, we have an a1 squared plus vector of A squared, magnitude of A squared, magnitude of B squared on both sides. So the only way that this equation is going to be true is if this piece is equal to 0. So if we have a1 times b1 plus a2 times b2, if that is equal to 0, then this is true. And that's important because what we started with is perpendicular vectors. Okay, so if just this little piece, I don't need to go through all of this work. If I just know this is equal to 0, I know that I have perpendicular vectors because then these two equations are the same. So this is what we call the dot product. In the way that we write this, so we say vector A dot vector B. As long as I know as long as I know I am dealing with vectors, this is not multiplication. This represents dot product. It is a different operation. But this is equal to a1 b1 and a2 b2, where these are the components of my two vectors. All right, so this is a new operation, and what this tells me is if this is equal to 0, I know that these two vectors are perpendicular to each other, or in terms of vectors, we would call that orthogonal. If this is not equal to 0, then they're not perpendicular and they form some other angle. All right, so let's use that in a couple quick examples. Okay, so find the dot product, determine whether they're orthogonal or not. So this is my a1, a2, this is my b1, b2. So you multiply your two x values together, you multiply the two y values together. So the dot product is going to be equal to 3 times negative 5 plus negative 2 times 1. So we end up with negative 15 minus 2, so we get negative 17. Okay, negative 17 is not 0, so that means that this is not orthogonal, meaning they do not form a right angle. And let's try that out for this one. So u dot v So we get -2 times 9. And then -3 times -6. So that's -18. The negatives cancel out. We get +18. And we end up with 0. Good. So that means that these are orthogonal, meaning they do form a right angle. And if we were to graph these both, I would imagine we would, looking at the picture, looking at the graph, we would agree with this as well. So here we go. Dot product. It's a nice, simple little equation. It's a little multiplication, a little addition, and it can give us some very useful information about vectors.